Hi everybody, this is Dave Barrick speaking. I'm going to do a quick walkthrough of a feature you may not immediately notice in the VPP engine, which is its event logger. Turns out that the event logger is down in VPP infra. It's thread safe and really very fast. One can log single events in 50 to 80 nanoseconds most likely. Figure like that is as a rough figure of merit. You don't end up ending up hurting yourself too much by using the event logger. It turns out, if you'll remember the startup sequence walkthrough I did a while back, vlib main happens very, very early, and we turn on the event log from first principles early on. If we look at the threading support, one of the things we do is to set up what are called tracks for the main thread and for each of the named types of threads, so that you can log events in a way where the graphical viewer that I'll briefly show you about, that we're going to upstream to the Linux Foundation in the near future, will display in a nice way. The idea being you can end up with tracks that correspond to threads, with tracks which correspond to control plane sessions, anything you like. At any rate, so the story is, if one goes and actually uses this facility, let's look at an example that I coded in the DPDK RSS input path, where what one does is to spin up a number of worker threads and have them look at particular RSS queues. And what this particular very simple event log is going to do is, every time we get a frame from one of the RSS queues, we'll scribble down into the event logger how many packets were in that frame, as it turned out. And the hint here is to use this guy elog track data to get a pointer to a datum which can be up to 20 octets. Here what I'm using is 8 to describe the event. The elog track is the particular track definition that we set up for this thread. So what you're going to end up with at the end of the day is something that looks about like this, which is to say, here we are, tracks for each of the two worker threads, and if we zoom in far enough and turn the event codes on, you'll see that we're saying, okay, the first worker thread got 39 packets in a frame, the second worker thread got 47 in a frame. Let's zoom it so it looks a little bit better. And oh, by the way, the time intervals here are about 3 to 4 microseconds between frames. The viewer is actually fairly sophisticated and worth looking at in some detail. Again, we're going to open source it in the near future. But the interesting thing with respect to the event logger is that it's very easy to add events, as long as you're not ridiculous about it, adding per packet events that occur all of the time. You can get away with processing some really high PPS rates, even though you're logging a certain amount of data. Well, let's actually go take a look at the logging process here, which is to say, here I have a GDB instance. If I run the vector packet engine up and ex set up a couple of 40 gig Ethernets, you'll see that we have the high performance path enabled. What I'm going to do now is to go turn the traffic generator on for a minute. And we'll clear off the stats, and you can see that we're processing basically 20 Mbps on 2 cores. The rates bounce around a little bit. Having done that, let's stop the traffic generator and go back into the debugger world. If we can figure out how to do it. There we go. Here we are. You'll see some input destination misses, whatever. At any rate, we saved the resulting event log, and now we can go run the viewer on the resulting event log, and you'll see pretty much what I had a moment ago, which is an awful lot of black ink until we zoom in to a reasonable depth. And you'll see here we are receiving lots and lots of packets. At any rate, that's approximately what the event logger looks like. Some good reference material for how to create event logs is actually in the test program for the event logger. Which is to say, as I said earlier, we end up with 20 octets worth of data. You can end up using enumerated strings for display purposes. You can end up using a simpler 4-integer format. And simply inspecting the test program and looking around at some of the code examples will tell you how to do particular flavors of event logs. You can do something as crude as actually formatting data. Now, the event logger itself is extremely quick, and we tend absolutely never to do this in a speed path, because if you start doing, printf in the speed path is absolutely to be discouraged. But again, testelog.c in VPP infra, VPP infra is a good reference for some of the event formats and some of the effects you can get. You can also look at elog.h at the main header to see in some detail the various kinds of data that are retained. Obviously the number of tracks is limited to 65,000. The graphical viewer we'll probably do another whole video on. It's capable of displaying order of magnitude 10 million events and thousands of tracks at the very least. That I've used it to track down per se, in another use case, I've used it to track down why does one of a million PPP sessions end up having an issue, those sorts of things. I apologize for the graphical viewer. It's crude and coded by a data plane engineer. On the other hand, it's very, very fast and highly scalable. At any rate, hope you find this interesting, and depending on what you're trying to do in the VPP engine, you may find this set of tools very, very useful.